This video is going to talk about the gas laws, which is where we really just talk about those three gas variables: pressure, volume, and temperature. We also talk about the amount of the gas, okay? So the moles of the gas. And we we talk about the relationship between those different variables if one thing is held constant. So we want to revisit these terms and make sure we understand and remember what these two terms mean. So directly proportional, remember, is going to mean that both variables that we're talking about are going to both increase or both variables are going to decrease. Inversely proportional, remember, is that one variable is going to increase and the other variable is going to decrease. Okay, so we want to make sure we know those two terms. So gas laws are all around us. Gas laws are actually really relevant into our worlds. You guys might have different levels of experience with the gas laws depending on what kinds of things that you're involved in, but all three of these pictures actually have something to do with gas laws. So let's look at the first relationship here, pressure and volume. This is the only inverse relationship that we're going to talk about. Pressure and volume. That means that when one thing increases, the other thing is going to decrease. And there's a couple of really good examples about this. Scuba diving. I personally have never been scuba diving. So some of y'all may have been scuba diving and can relate to this more and can give me actually a little bit more information. But one of the things that they talk about when scuba diving is really coming back up to the surface. As you go down and deeper into the sea, the pressure changes, okay? And the pressure gets greater as you go down, which means that the volume is decreasing. If you come up too fast and the pressure is decreasing as you move up, the volume is going to increase. And if you come up too fast, that could cause your lungs to expand at a high rate. It could cause your eardrums, your ear canals to expand quickly. So it's really a great idea as you're ascending to take your time, stop every so often, check your apparatus, whatever it is that they tell you to do. Again, I have never been scuba diving, so I don't know. Another example is when your ears pop on a plane. Our ear canals are filled with gas. And when we're down on the ground, the pressure is greater. When we move up into the air, because there's less gas particles, the pressure gets less. And because the pressure is going down, the volume is going up. Well, the volume of that gas in our ear canals has to have somewhere to go, so that's why our ears start popping, okay? Now, we want to remember that pressure is related to the amount of collisions with the side of the container. So you can see with these pictures here, when we have a large volume, the gas particles are going to hit the sides of the container less than when you have a smaller volume. The same particles are going to hit the sides of the container more frequently, and that's why the pressure increases when the volume decreases. The next example is the temperature-volume relationship. And this is a direct relationship. That means when one increases, the other variable is going to increase. Now, I love talking about the hot air balloon during this example. Again, I've never been on a hot air balloon. I'm kind of afraid of heights, so I don't know if I'll ever do it. But when hot air balloons go, we know that they have to turn on the fire in order to fill the balloon. So when they heat up the air inside the balloon gets bigger. When the balloon gets big enough, the balloon will go up into the air. Now, in order to come down, they turn off the fire, they start to cool that air, and it allows the balloon to start to deflate, and so it can come back to Earth, okay? Baking bread is another example. When you're baking bread, one of the reactions produces carbon dioxide, which is a gas, as we know, and that gas is going to expand, causing the bread to rise. The temperature-pressure relationship, this one is so relevant right now because, as we know, we're going through an ice apocalypse, and it's very cold outside. If you go out and check your tire pressures, chances are your tire pressure is very low. Because when the temperature goes down, the pressure is going to go down. And so a lot of times I love to teach this unit when we are getting into February and it's getting cold outside. It always happens to me where I come into my car, my tire pressure light is down because it's gotten so cold. You just don't want to overinflate those tires, because once the temperature goes back up, like it's supposed to do this weekend, go back up to 70 almost, your tire pressure could be too great if the temperature increases so drastically. So really be careful about overinflating tires when it gets that cold outside. The Instant Pot, I love my Instant Pot. I used it last night to make some chicken and dumplings, but that's another good example of the temperature pressure relationship, because as it heats up, that pressure builds up, thus sealing in all of that pressure and allows your food to cook. And then the whole mechanism behind firing a gun also has something to do with that temperature pressure relationship, because when the trigger is pulled and it ignites the gunpowder, that increase in temperature causes the pressure to build up behind the bullet, pushing the bullet out of the barrel. So we're going to be looking at the combined gas law. This has all of those different relationships together. So it has the pressure, the volume, N is for moles, so the amount of gas, and then T is for temperature. Now, when you're using this combined gas law, very, very, very important, the temperature must be in Kelvin. Even if you're starting with a temperature in Celsius and it asks you to find the temperature in Celsius, you still have to convert to Kelvin and then convert back into Celsius. It will not work if you use the Celsius temperature. It has to be in Kelvin. With pressure and volume, your units can really be in any of those pressure units that we talked about, or it could be in any volume unit as long as the units are the same on both sides. Okay, our next video is going to go over some examples of the combined gas law.